Hello everyone. Today we will perform the Charpy impact test to determine the impact strength of the material like mild steel or cast iron. We know the impact strength of the material is calculated when we apply the sudden load on a material. The resistance offered by that material for that sudden application of the load is called as the impact strength of the material. So there are two types of impact test can be performed. One is a Charpy impact test and the second one is a ISOD impact test. So depending on the type of the specimen specification, the test is either a Charpy impact test or ISOD impact test. So today we will perform the Charpy impact test. So the objective of this test is to find out the impact resistance of the mild steel. Then the apparatus used to perform this test is impact testing machine. So this testing machine you observe in the figure is called as a impact testing machine, and the operator is there to perform this test. So our first step to perform the test is test for friction loss is conducted by adjusting the pointer to 300 joules. Then the pendulum is released by operating the lever without keeping the specimen. So here there will be no specimen is attached on the anvil, and we have to measure the loss of energy due to friction only. So here you can observe the display unit which can give the energy due to the striking or due to the friction. So by using that lever we can release the pendulum. So this part is called as a pendulum, which consists of a striker inside the pendulum, so it can break the sample whenever we perform the test. Now in first step we have to just release the lever and measure the impact energy or loss of energy due to friction without keeping the specimen on the anvil. So once specimen is released, the display will give you the value of the loss of energy due to friction. So it will be equal to 1 joule now, the loss of energy due to friction without keeping the sample on the anvil. Second step, the Charpy test specimen is as per Indian standard, that is IS 1499 to 1977 is used to conduct the test. So this is the actual specification of the sample used for the Charpy test. So the length of the specimen is 55 mm, then width of the specimen is 10 mm, and thickness of the specimen is 10 mm. Means the standard specifications for the sample is 10 by 10 by 55. So the cross section is a 10 by 10 and 55 mm is the length of the sample. Then the notch is also made up at the center of the sample. So to locate the fracture point we are providing the notch into the sample. So the depth of the below the notch will be equal to 8 mm, and the root radius of the notch is equal to the 1 mm. So these are the some specification of the sample. Then for a striker or a hammer, the angle at a tip is 30 degree. Next step number 3 is select the Charpy test specimen. So you can observe there are two types of samples are there. One is cast iron material and second one is a mild steel material. So we perform the Charpy impact test on the mild steel material. So we consider the selected material as a mild steel. Here the length of the sample specimen will be equal to, now calculated by the software, is 58.87 mm. Then the breadth is 9.3 mm and depth is 9.5 mm. Then the depth of the notch is equal to 5 mm. So this is the now specimen specification for this mild steel sample. Next, the Charpy test is the test specimen is placed in the position as shown in the figure. So here we have to keep our sample in step number 4 on the anvil. So this is the anvil, and we have to keep this sample onto the anvil so that it will be like a simply supported beam type arrangement is there. So we can keep the sample on the work table. So this is the nothing but keeping the Charpy test specimen is placed in the position as shown in the figure. So this will be the anvil, and on anvil we are keeping the sample. Okay, then the notch side will be the opposite to the striker. Okay, next the next step is to the pendulum is released by operating the lever. The hammer strikes against the specimen and it breaks it. So you can observe here the position of the sample, and when we release the lever, when we release the pendulum by using this lever, it will strike at this point opposite to the notch, and it will break, and we can measure the energy due to the striking energy at the screen. So once we release the pendulum, we will get the striking energy. So test piece was not broken by the striking energy of the testing machine, so the impact value obtained is infinite. So here in this case the sample is not broken down, so we are not getting the value for the impact energy in step number or trial number 1. So go for the next trial. So here we can make the observation that the energy loss due to the friction will be equal to 1 joule. Then the total loss of the energy during transit of hammer, that is Et, equal to indefinite, and the energy for failure of the specimen will be equal to indefinite. Means we are not get the results at the sample does not get break. Now we will go for the next trial. Same sample specification we consider with these dimensions. Now again we are following the same procedure. We are keeping the sample on the anvil in the simply supported type. Then we are releasing the pendulum by using this releasing lever, and we are going to measure the energy. So here we can observe the sample is break now in trial number 2. So we will get the 48 joule as energy, the total loss of energy during the transit of the hammer Et, 48. Then the energy for failure of the specimen is equal to the total loss of energy during transit of hammer minus loss of energy due to friction. So that will be 48 minus 1 is equal to 47 joule. So the loss of energy due to friction is equal to 1 joule. Then the total loss of energy during transient of hammer is equal to 48 joule, and the energy for failure of specimen is the difference between the total loss of energy during transient of hammer and loss of energy due to friction. So we will get the 47 joule as energy for failure of the specimen in trial number 2. Now we will go for the trial number 3. Again we are taking the specimen as a mild steel with these specifications. Then we are following the same procedure for trial number 3. On anvil we are keeping this standard specimen. So this is the position of the specimen on the anvil. It is a simply supported type. Then here we can have the energy we will get once the striker strikes onto the sample. So by using that lever we can release the pendulum so that it will get the energy after striking. So 43 joule energy will get. So sample gets breakdown in trial number 3. So the total loss of energy during the transit of hammer Et equal to 43 joule. So the loss of energy for failure of specimen is equal to the loss of energy during transient of hammer minus loss of energy due to friction. So 43 minus 1 is equal to 42. So we are made the observations that for third trial 43 joule is the loss of energy during transient of hammer, 1 joule is the loss of energy due to the friction, and 42, that's why we will get the 43 minus 42, 43 minus 1 is equal to 42 as a energy for failure of the specimen in trial number 3. So here we take the different trial to get the accurate value for the failure energy for failure of the specimen. So here we take the average of this, which will become as a 44.50 joule. So in this way we can calculate the impact energy for the failure of the specimen in joule using a Charpy impact testing machine. So in this way we can perform the experiment, or we can get the impact energy of the mild steel material. Now we will perform the same test for cast iron material also, so that we can get the impact energy or impact strength for the cast iron material. So here we have to perform the again loss of energy due to the friction without using the sample, without keeping the sample. We have to release the pendulum by using the lever. So 1 joule we are getting the loss of energy due to the friction. Now these are the sample specification, again length 55 mm, width 10 mm and thickness 10 mm, which is a standard specification as per Indian standard IS 1499 to 1977. Now in previous test we performed the impact test on the mild steel. Now we are going to perform the impact test on cast iron material. So we select the cast iron as a specimen material. Then these are the specification will come for that standard specimen. Now we are following the next step, placing the specimen onto the work table or anvil. So we are keeping the sample or specimen on the anvil in a simply supported type. Then we are following the next step as determining the pendulum is released by operating the lever. The hammer strikes against the specimen and it bends. So in trial 1 we will get the loss of energy during transient of hammer. It is equal to 4 joule, and the energy of failure of the specimen will be equal to 3. Next, therefore the loss of energy due to friction is 1 joule. Then the loss of energy due to transient hammer is 4 joule, and we will get the energy for failure of the specimen as a 3 joule. Next, again we have to follow the same for next trial. Same procedure we have to follow, keeping the sample on the anvil in simply supported type. Then release the hammer. We will get the 7.5 joule as a energy after striking. So 7.5 minus 1 due to friction, we will get the energy for failure equal to 6.5 joule. This is the trial number 2. In trial number 2 for cast iron material, we will get the energy for failure 6.5 joule. Now again we have to go for the trial number 3. Same we have to follow the procedure. We have to keeping the sample on the anvil in simply supported type. We are releasing the lever and observing the value of energy onto the display. So here we get the energy for failure of the specimen equal to 5 joule. So for all these 3 trials, we will measure the energy for failure of the specimen. So for trial number 1 it will be 3 joule, for trial number 2 6.5 joule, and for trial number 3 it will be 5 joule. Now we are taking the average of that value. So the average energy for failure of the specimen will be equal to 4.83. So in this way we will get the impact strength for the cast iron material.